Hey guys, Alan from Hack Gadgets here. I got a little device in my hand here. We've all seen one of these. You dial in the temperature you want, and it turns your furnace on when it gets cold. The issue with this thing is the location I want to mount this in isn't the optimal location that I want to monitor the temperature. There is some ones that have wireless sensors that you can actually mount the sensor somewhere different than the location of the thermostat. But I want to do it on the cheap. This was already in the building. However, it was in one of the tenant's suites. And, I don't want to have to bug a tenant whenever I have to adjust the temperature. So I'm going to mount this in a mechanical room. And I'm going to mount the temperature sensor that's in here, as long as I can get it out of here, and mount it remotely. Let's head over to the bench and see what we can do. Okay, so here's the thermostat. It's something I acquired when I purchased the building, so I haven't actually had a heating season in this building yet. And we can see it's very basic. However, the system in there is really simple. It has an on and off. It's basically a radiator, a hot water radiator system. So basically this turns on, it fires up the natural gas heating system, which heats up some water, floods it over through all the rads with a big pump, and that's how all the suites get their heat. So it's either on or off, and either all the suites are getting heat or all the suites aren't. I have a future plan. I was hoping to get it done this year, but not quite in time. But the future plan, maybe for next year, is to use some of these sensors. So these are temperature and humidity sensors. Not that humidity matters, but it'd be interesting to monitor. And what the future plan is to mount these in every suite, and maybe places like the mechanical room and laundry room, things of that nature where you also don't want them to freeze. And then what the future plan would be is to make sure that all of the suites have a nice even temperature, keeping sort of minimum temperatures in mind, and also that the rooms like the laundry room stay above a certain temperature. I don't care if the laundry room is at 15 degrees, but I care if the laundry room is at 7 degrees, let's say. So watch out maybe next year for this plan here. And the other nice thing would be using something like the ham radio, APRS I believe it is, something like that, to actually transmit the data so that you can actually monitor it remotely. That would be ideal. But anyway, this is going to be a very, very simple project. Hopefully, as long as I can get the temperature sensor out of here. If this thing is surface mounted, it might be a no-go, but I'm assuming it probably won't be. Okay, so a little notch here. I've already taken this off because I did have to take the screws out to get this off the wall, so I have seen in here before. So this is what we got on the inside. Quite a nice liquid crystal display, and the interface on the outside is basically these two buttons, and really it's either off or heat. That's the only user control. So when we push these two buttons here, what that does is it actually allows us to, okay, it's off right now, I'll put it to heat. That allows us to set the turn on temperature, and 23 degrees, that's actually the Celsius temperature in this room right now where this is being recorded. And so we could say that, let's say if the temperature goes below 22 to turn on. And there'll just be a relay in here, and I believe the connections were connected onto these ones here, so it'll just be a dry contact relay that changes state to tell the system to turn on. It runs off of 2 AA's in series, so we just got a simple 3-volt system here. And yeah, we can see it's basically chip on board here, so we won't be able to see any sort of microcontrollers because this will be obviously a custom die that's built directly onto the board. I don't have the manual for this, but we can see there's obviously a program jumper that's been cut here for some modes. And I guess, so we don't have any cutouts for buttons here, but obviously this is probably a multi-use board here for different versions. There is some gold fingers here which are you know, some of those membrane buttons would be on some models, obviously. Okay, so not sure what this is. Labeled S9. That's interesting. If there's some if there's some numbers on there, maybe we can look up some documentation. Okay, so we got a crystal up here. This is one that can handle different events at different times. So obviously this is keeping track of time. We have an LED for backlight here, and we got a couple screws. So let's undo these screws here and remove this board. Let's see what's behind here. Okay, 2 screws were removed, and this is just a snap together construction. You can see we just have a little prying tab here and another one here at the bottom, and it looks like all the connections are done through this flexible ribbon cable there. So I've actually removed the batteries, and you can see this thing is extremely low energy here with the LCD display. It's basically running on batteries, which is a good thing, because then you can change the batteries and you're not going to lose your programming, because this thing can obviously last quite a while. Just hang it out on whatever charges lingering on the capacitors. So I'm just going to pull this off here. Just a couple switches at the bottom. So these switches are external. There's another switch down here, electric or gas. So I'm just imagining that electric or gas is maybe just the time delays between switching, maybe something like that. Maybe when it's on one of the modes, it waits maybe after it. Oh, here's a low battery symbol. Change the batteries. It probably waits X amount of seconds before switching, just so it doesn't you know, chatter the relay back and forth and do some crazy stuff to the furnace controller. So very simple construction on this bottom board. We can see some jumper links in here. So this is obviously single-sided construction here. So they've saved some money that way. And very simple. Here's the actual relay that's obviously doing the switching. That'll be connected to this guy here directly. Not much to it. And the back of this board, yeah, this is also single-sided copper. So it's all surface mount on this side. And we have a few jumper links on the back here. And interesting, these little jumpers here that have been cut, they're actually front soldered. Okay, so I'm thinking the only item that sort of sticks out is this little blue guy here. Let me see if I can make it focus on there. So, you know, it could be anything in there. It's not marked on either side, and it looks like a capacitor, you know, but it is also a proper size for a thermistor. And so just to show you how confusing it can be, you know, so does that look similar to this? This is a 0.1 microfarad capacitor, you know, sure does. Can you tell the difference? Other than a little bit of size, not really, but I'm thinking this is a device. But what I'm going to do is I'm going to put an ice pack beside here, and let's cool the sucker down and let's check it out. Okay, so batteries are back in. Let me zoom in a little bit here, and got a little ice pack here, nice and cold out of the fridge. All I'm going to do is I'm just going to rest this guy on here, and let's see if we can make this temperature sensor read colder, and we should see this 23 drop. Okay, so it took quite a while, but we got it to cool down to 20. I think there's a very slow sort of progression, because I'm assuming this is actually much colder than 20 degrees. This probably took about a minute to cool down to this. So what I'm thinking is if there's drastic changes in temperature, it probably doesn't update right away. And I can imagine that's probably just to prevent things like if this was mounted near a door, every time the door opened, you know, it would get a blast of cold air, and this thing would immediately turn on. So they're probably having some really big hysteresis in there, so that it takes a long time for the cold to actually affect it. It's looking for more gradual changes, which is, you know, generally what you get in the house anyway. So we are going down, and this is the only thing that I was touching with this cold here, just right here. So we have found the temperature sensor. It is this device right here, and thankfully it is surface mount. And the other thing I'm just thinking, let me just short this out. If that is a temperature sensor, shorting it out shouldn't cause any damage, and we should see a drastic change in the, or some change here, probably like an invalid temperature or something we'll get. There we go. So it doesn't know what the temperature is, it's just showing dashes now. This is the set temperature, so this one is nothing. So if I release that, it'll probably go back after 30 seconds or so. Let's see what happens. And now it's at room temperature, or it'll start to be going up from room temperature. So, and there we go. So we're at 16. So it's sort of reading the actual temperature now, I'm sure, which is well below the actual room temperature in here, which is around 23, 24. So we're slowly warming back up to ambient, and now we know where it is. Let's desolder that guy. Okay, pop the batteries out. I'm going to be desoldering that with the Heiko 808. It's a desoldering gun, and if you've never used a desoldering gun, they're awesome. And this one I think is the best one I've ever used. If you've never seen one of these types, what it basically has is it's trigger operated. It's been plugged in for a few minutes, so it's hot. The tip heats up just like a soldering iron. The back has a vacuum pump, and basically you can see the tip has a hole in it. So what you do is you actually place the tip over top of your through-hole device right on the lead. You heat it, you do a little swirl to get that lead molten, or the solder around the lead molten, and then you just give the trigger a pull, and it'll suck all the molten solder right in. So it sucks it right through the tip into this chamber here, and this chamber basically has a filter that catches all the solder, and so the filters are replaceable, the chamber is cleanable, and so you're just good to go. You can just do many of them. So let's see how this thing works. So we got to desolder those two leads right there. I'll place it on, a swirl, little pump, and there we go. So that one there is done. Now let's do number two. I'm going to place it on, give it a swirl, give it a pump. There we go, 2 for 2. So let's see how this thing worked. It was glued in also, so I'm just going to pry it off. A little bit of glue on there. There we go. No sweat. So if you're using, braided copper braid, or one of the desoldering pumps, the manual one, the one you do the plunger and you give it a press, man, this thing is 10 times better than that. So here's the actual device. So this is the one we're going to be mounting remotely. It's just in a little holder. And I'm going to be mounting it in this little project box here. So this box will be mounted in the location that this used to be. And this has a little location for some wires to go in. And ideally I wouldn't use this connection for the wires, but I don't have the ones I would like to use. I've run out. So I'm just going to probably just hot glue this right to the back plate here. And so I can have nice access to the screws. The temperature sensor will be soldered directly to these. And there's a nice introduction for the wires to get terminated. And as far as holes go, what I would like to do, I don't have time for this, but what I would like to do is actually make a drill pattern, so I could have a really nice sequence of holes on here. I'll probably just maybe just plunge a bunch of holes with the soldering iron, or just take a drill to it and just make a bunch of holes down the sides and the front, just so that it can get some nice airflow but still be protected. So let's move on to that. Okay, got a nice big fat tip on here. Nice and beefy. We're just going to punch some holes here with the my crappiest tip I got. And I got the iron cranked right up to 480 80 degrees Celsius, so it should take nothing to punch some holes in this. And I'm just going to just make a nice little pattern here. Again, it would be optimal to do it, you know, in a way that... Oh, and of course I... There's a standoff in here, and I think that's exactly what I hit. Let me move beside that. There we go. Okay, so there's a hole. Let me just make a bunch of holes. And if you don't have yourself a set of these helping hands, you should get them, because there's no real better way of holding two parts together and then being able to get in there with solder and your soldering iron than using a set of helping hands to hold joints together while you solder them. Okay, so this guy's been soldered on, and all we have to do is stick it on to the back here. I'm going to use the mini heat gun for this one, and I want the temperature sensor, you know, somewhat centered. So, and obviously the wires are going to be coming in the top here, so I'm just going to apply some hot glue right on the bottom here. And I'm going to be quite generous with it. If I thought about this before, what I would have done also is scratched up the surface a little bit so it had something to notch into, but oh well, I think this will adhere okay. And I'm just going to remember that when it's in, just want to make sure that I can still access the screws without them being filled with glue or blocked, and it looks okay. And I'm happy with that positioning. Okay, so this side is done. This is going to be closed up. That's going to allow the air to get in there. I'm going to have a wire coming out of here, and this is going to be bolted to the wall. I'll keep it in this position here so that it dries, and once that dries, it'll be done. Okay, and what I'm planning on doing is also mounting one of these same terminal blocks on this guy. I'm going to be utilizing the same wire. It is twisted. It's not shielded or anything, but it is twisted wire that goes up to this location, and it's not going to be very far from where this is going to be mounted, probably about 15 feet. So I'm not thinking I'll have any problems with a standard wire connecting these two devices. I will test it on this end here just to make sure that it is monitoring properly. And as far as locating this goes, you know, I could just, you know, pop it right here. However, you know, that would look kind of ugly. So I think what I'm going to do is just hot glue this in position. Probably something like that. So I'll have, or maybe over here. So I'll have two wires coming out of here for the relay contact, and then two wires coming out of here for the temperature sensor. So it'll be, you know, a nice little unit here. Okay, so terminal block is mounted, wires are run under here. Ample amounts of hot glue here to hold things in place. That should be fine. The only thing I had to modify here is you can see where the wires came through. There was a piece of plastic there. Just a little bit of melting was just enough to allow those new wires to feed under. And that's held in place underneath here with a few dots of hot glue also, so it's you know, stays out of the way. And that just snakes under here and comes right over to this brand new terminal block. So it doesn't have to look pretty because nobody will ever see that. It just has to be functional. Okay, so everything is wired up. This is just one of these desktop units here. So we got about 24.2 degrees Celsius in the room right now. And we're showing 24 degrees on the system. So we have the temperature sensor hooked up right here, and it's just feeding around. This is just a loop of wire. It's around 35 feet, so this is actually longer. This is just station wire. This is longer than what is actually going to be used in the field. So I just wanted to make sure that, you know, this being plugged in remotely wasn't going to be an issue, and clearly it's not. So this is not going to be the sensor here, or the wire connecting to the sensor. This will be something a little different. So when it is all buttoned up here, you'll just have a uniform cable coming in, and that'll be the unit that's mounted in the suite. This will be mounted in the mechanical room, and we're good to go.
For more information, go to hackedgadgets.com.